the third module is the rough plan of the course content. So again, so let's come back to this reference view of traditional programming versus the machine learning based programming. And so we are, so just a very vague way to talk about it is we are using data to generate algorithm. In fact, we are generating model. Okay, so what is basics of machine learning? So the goal of, this is a pretty big person in machine learning, one of the first few machine learning researchers in the field. I like his definition, so just keep using that definition. So the goal of machine learning is to build computer system that can learn and adapt from their past experience. So the experience is in the form of available data examples, and also called as, we can also call those as instances or samples. And the available examples are defined and normally described with some kind of properties. So which use a mathematical way to talk about it is we're representing the past data as data points in some kind of feature space X. So now, okay, so let me introduce you a few notations we're going to use a lot. The first notation is X. The second notation is Y. And the third notation is F. So when we talk about data and output, we normally use notation X to represent data, notation Y to represent output that we care. And we use that F function to represent the model generated from our machine learning like training. In fact, this is training. So this page is more like explanation about how I organize the following slides about basic plan. So this is actually called Bloom's learning taxonomy. So the basic learning, so my style of teaching is always I'm trying to tell you why I'm doing something. And it's normally have some kind of learning principles behind, there's some reason behind. So I will normally tell you the reason, then I'm act according to that reason. So for people to learn, their learning it's normally starts from remember the basics, like your language learning, you remember the basic letters, words and phrases, grammar. And the next level is to understand, then the next level is apply, then the next level is analyze, and then the next level is evaluate. So in the next few slides, I mean, you just have to remember something. And because this is the most basic learning module. So there will be a few notations you have to memorize, like the X, Y, and F. And the next level is understanding. So I'm going to tell you why I'm telling you those notations. And then the most important techniques I always use in my teaching is something called analyze. This analyze, it's always decompose things into chunks. And you're going to understand why I'm saying this in the next few slides. So remember that. So I will always use a more analysis-based style to teach, not just a knowledge, like a spoon feeding or like just code-based. I normally use an analysis-based learning style or teaching style. Okay, so that's like a background. Now let's go to the next. Okay, so this is about, I told you X and Y and F, right? So how do I use that X, Y, and F? So the simplest setting in machine learning is something called supervised learning. And the fundamental process of this supervised learning is to I'm looking for F function that can map from X space to the Y space. So the differences between the Y and Fx on each example is very small. So this is a lot of things to memorize, but it's in fact just let's use example is For example, this is more like Amazon book review. So I believe this book is not at all helpful since it does not explain thoroughly of the material, and then blah, blah, blah. So we can represent this piece of English text is my X, and I want to have a function to predict, is this review positive or negative about the product? So this is a basic X and Y, example of X and Y, and also a F function. So then what should a function look like, right? I mean, a specific scenario in the previous page, and yes and no, which essentially that output or that Y space is just binary. So it's a binary Y, and then let's make it even simpler. So assuming, let's just see, it has, is this review has the words, how many words like good in that review? How many words maybe not in that review? So let's just make it really, really simple. And so I'm just trying to, like we know the X, right? And we know the X is the text, the property of the that text. We know the Y is yes and no. And now we need to learn F. We need to have some assumption on the F. So in this case, let me just assume it's a linear function. So this still sounds pretty dry, right? So let's see, what do you even mean a linear function? A linear function is really just, in this case, assuming I'm representing many text examples like the one I just showed you. I know the blue points are the positive reviews, the red points are the negative reviews. And then I use some kind of properties to put them in this two-dimensional space. And then I'm just trying to look for a separating lines to separate them into two classes. So then this is my F function. So I think because you all already learned about linear algebra, so how to represent a line, a linear line in a Euclidean space. It's very simple, right? To represent a linear line in a Euclidean space, you just need a slope, you need an intercept. So there's only two parameters define that line, and then every line in the two-dimensional space can be represented as W transpose X plus B. And this X is a two-dimensional space in this case. And the blue point here represent the positive zone, and the negative point here represent the negative zone. So when I'm given, so let me see, so again, so when I give you the training data, so that's a group of XY pair, my job is looking for a linear line doing the separation as well as we can. And there's a few concepts related to here, but now we know what X looks like, we know what Y looks like, we also know what F looks like, right? And then, but my true goal is actually not just to separate the blue and red points well. Okay, so just to echo again, you can see, right, what I give you is X1 pair. There are many points, blue points and the red points, then it output a linear separation line. So this F just W transpose X plus B in this form. This is to echo that previous versus the traditional programming. So like I told you, even if you find the line, but that's not the final goal. The final goal, in fact, is I want my line to truly predict the future points well, to truly predict those future points. If they are the positive zone, they are going to be predicted as positive. If they're in the negative zone, they're going to be predicted as negative. So to be able to predict on the future points well, this is called generalization. So which means the blue points and those points very close to the blue points, they are all positive. And for the red point, if they're all very, for the future point that are very close to the red point, they're all negative. And my f is really well that in that sense, because my f function predicts the future points really well. So this is the most fundamental objectives in machine learning called generalization. So what the phase I just tell you, so this XY data and output, then go to a computer, then give me a model. It's called training phase. But this is not every phase of machine learning. In fact, there's also a phase called deployment phase or testing phase. So I already have my F model. I have a future question point, and it will predict what is the Y of that question point. And this is called deployment or testing phase. All right, so let me clean up this. So now, please start to memorize a little bit because this is more like a basic concepts of machine learning. So what we just covered there is, what do you mean a F function? So F is my model, right? But there are different kinds of F function, right? In a specific one, you assume it's a linear line. And then specifically what you mean is, what is the W and B for that F function? And then a second concept is the training data. It's the XY pair, the blue point, the set of blue points, and the set of red points in the previous figure. And then the step, we are trying to figure out where to put that best separation line. It's called optimization. The line is searched by minimizing something called loss function or cost function. And so in the end, I'm trying to figure out where to put the line that best, that minimize the differences of fx prediction, and the true given y. So this is called loss function or cost function. It's normally defined on the training data. It's the training loss. It's the one you need to optimize to look for what is the best W and the B.